share my screen. Okay, let me know if you're not able to see PowerPoint slides on your screen. Okay, let me recap some of the equation before we jump into the exercise. Now, before this, we cover the general equation to get the stiffness matrix. Apologize, this is a capital K. Once you, not capital, small k. So this is just a conversion from local to global. All right. So as if you can see that the matrix over here, you have AE over L, but inside the matrix bracket here, you are seeing cos and sine. So when you're seeing cos and sine inside the bracket, meaning you are doing conversion from x prime axis to x axis. Okay, so from local to global. Okay, so just remember this equation is important for this session, and the rest I will show you in the tutorial today. Okay, so we have covered one of the exercise previously. So today we're going to look at application of the equation also by give you another dimension so that you know how to do it in your coming test or exam. All right. So your test is going to happen in another 2 weeks time. It will be covered chapter 2 and chapter 3. Okay. Yeah. So you're given 1.5 hours to solve two question, right? 1 or 2 question. I'll give you more detail as it get near, but it will come from chapter 2 and chapter 3. All right, so let's look at this diagram over here. So before you solve, you look at the diagram and see what you have in the diagram. Over here, we have 2 elements or 2 bar. So labeled by 1 circle and 2 circle. So element 1 is 1 to 2, point 1 and point 2. Element 2 is connecting point 1 and point 3. And then you look at point 1, there is a roller constraint here. We have a roller brake here. Okay. All right. So and then you're given the distance between point 2 and point 3. You have a 3 meter here. You have a length of 3 to 1 here, which is 4 meter. Okay. So I hope you can see a triangular here. Once you see triangular, you're able to find the theta over here. Right? And you are given a reference axis X. This is one of the format in your coming test or exam. We will purposely change the axis. All right. For example, this tutorial question, we change the x-axis to a non-normal direction. Okay, normal direction is to the right, right? So in this example, your x is going up, your y is going to the left. So take note on all these details, because these are the area where student will overlook and you will solve it in the wrong way. All right, and you have an external force over here, which is P equal to 1000 kilonewton. Remember to carry this kilo in your answer later on. And you have a delta, which is a displacement, not displacement, but there's a distance that from point 1 to the roller ball here, or the wheel here, right? The delta is 50 mm. So remember to change to unit SI when you solve, because when you find the forces later on, you need to use a unit SI. And even though you're given the symbol or theta 1 here, theta 1 means you're referring to from x to x prime. Okay, again, your theta is referring to x to x prime. Remember, your theta, you are referring x prime. Sorry, you're referring x to x prime, meaning from here to the element. Okay, So for element 1 is from here to here, and the direction is anti-clockwise positive. And for element 2 is from here to here, x to x prime. And this one is x prime 2, means element 2. Okay, take note now. These are all the important concepts before you solve the question. Okay, now let's look at the problem statement that you can see on your screen here. We have two bar truss. Again, the definition of truss means that you have more than one bar element connected with a pin and constraint. Now determine the displacement. You need to find the displacement in y direction. In this case, your y direction is a little bit different from the normal one. Means in the y direction of node 1, meaning normal axis means a notation that we use, right? So for example, x we use u displacement, y you use v symbol for y axis, z you use w. Okay. So in this case, you are going to find the displacement at point 1. So the parameter that you're going to calculate is v1. Okay, v1. Axial forces, you need to find axial forces, which is the F. Each element, if you see the each element means small f. Okay. Capital F means external force. So a force of P is 1000 kilonewton applied at 1 that you can see from diagram in a positive y direction. This is a guide for you, a guideline for you that is stressed against the direction of y. Okay, it keep giving you hints that look, the direction, the axis direction is different from normal one. This one is to the left is positive. While node 1 settle an amount of delta 50 mm in the negative x direction, meaning node 1 is moving in a negative 50 mm direction, mean it opposite the x direction here. Given the E value in giga Pascal, area, cross-section area of the bar is 6 times 10 power 4 meter square for each element. Length element is shown. Okay, before we solve, I want to ask question. Okay, let me ask. I'm interested to know what is the length of the L for element 1. Okay, pull your calculator and then try to calculate. This question I'm going to ask. Let me see. I'm going to ask Ajmal. Are you there, Ajmal?
Yes,
what
sir.
is the length of element 1?
5, sir.
5, huh? So any one of you don't understand why 5? Let me know. Let me know if you don't understand why L1, how you find L1, the length of L1 is 5. So you understand?
Yes.
Can you explain how you get 5?
Square root 3 square plus 4 square.
Okay, good. All right. Excellent. Huh? So all of you know how to find. So this one, there's a calculation for this one. Once you find that this one, the length is 5 meter, you get 1 point for this length. Okay, so don't skip any steps that that help you to determine the length of this one, because later when you calculate the AE divided by L later on, there's a calculation inside the matrix. You need the L also. So you need to prove that how you get this L for each element. Okay, so before you start solving, you look at the question and try to look for any missing important data that you need. For example, the length of element 1 from point 1, point 2 is missing. So you need to find the L first. Okay, then the second one is the data here. Or data here also can. Because you know the length, not length, but you know the, because you know the height of this one and this one. All right. Okay, Chia, can you help us to find what is the data of, okay, let me erase. Can you find what is the data of this one? Chia, can you help us to find?
Yes,
Where is the value? So you help to standby answer. After Chia give me answer, you try to check whether his answer is correct or not. So
36.9.
36.5.
36.9.
Okay. Can you give in maybe 2 decimal place?
36.87.
Okay, good. Sue, what answer you get? Sue, are you there?
Yes.
Yeah, what is the data for the one that I label on the screen here?
Mm.
So do you have your calculator step by your side?
Yes.
Yeah, what is the data there? Okay, how do you find, what is the procedure? What is the mathematic procedure? How you find the data? Can you explain? Maybe you don't need to tell me the exact number, but how you find it?
Mm. So I think I forgot about the mathematics.
You forgot. Okay. Chia, can you explain to Sue how to find the data?
Because tangent theta is equal to the O over A. So I use, since the O is 3, then A is 4. So I use inverse tangent and find the data.
Okay,
Oh,
excellent.
okay.
So
I
you
know
get it
they
now,
like
huh?
the sine equal to OA and cos equal to AH. Okay.
It's not sine, it's tangent.
Oh, tangent. Tangent. Oh, sine is
Tangent equal
OH.
to opposite divided by the side.
Okay. Yeah. Okay. So
Okay.
sine is OH.
In this module, you need to recall all these trigonometry things. Okay, so you need to be careful a bit.
Okay.
Okay, Brian, I assume your mic is having problem, but you can text the answer later on when I ask question, right? Okay, now the next one, I'm going to ask something about the bounding condition before I show you the steps of the solution. Okay, now let's go for easy one. For point number 2. Maybe this one. Okay, Brian, are you there? Brian, is your mic working?
Yes, sir.
Okay, good. Brian, look at the screen. And if I look at point number 2, What is your displacement at point number 2? What is your displacement? What is your U2 and V2 or maybe W2? What is the value? Ashma, you ready the answer for point number 3? I'm going to ask the same also.
Was 0.
0 for
0.2.
U2,
U-
V2, and W2. Why W2 0? Why I
Because
can say
W2.
W2?
Yeah.
Huh? Why I can say W2 now is 0?
It's in the Z direction of that. We are
Okay.
not.
Okay. So you're not seeing Z here, right? You're looking at X and Y. So Z, if not shown, then is 0. Okay. So you're only looking at 2 dimension, U and V. Okay, same. Ashmal, what is the displacement at point number 3?
0 also.
Also 0 for
Direction.
U3, V3. If we ask in 3D, then W3 also inside. All is 0. Huh? Okay, good. All right. Now let's look at point 1. Point 1, the displacement is given. Huh? This one. Okay, Brian, look at point 1. You are given this parameter, delta equal to 50 mm. This one referring to U1, V1, or W1. Which one?
So I think it's in the X direction.
Okay, so what does it refer to? U, V, W.
It will be U.
Again?
U, sir. U.
Okay, good. Excellent. All right. So there is a displacement in U, and also there's a displacement in Y, because you have a roller here, so it will try to move. And you try to imagine there's an external force of P that is pressing from the right. Okay, pressing from the right here. So when you imagine if you are the steel bar or something that able to elongate and you push from the right hand side. So this roller, this point is going to move to the left. Okay, it's going to move to the left. Right, and yeah. So these are the important concepts before you start solving. Okay, all right. Next, I'm going to show you the steps already. First, you call out the K matrix for the conversion. CS, C, S square minus CS, so on. This is a standard matrix. When you need to use this matrix again, when you are considering X to X prime axis. And each one give you one set. Okay, this one, if you have 2 elements, then you have 2 sets. This one you do 1 set for element 1, then you do second set for element 2. Remember, I teach you about the table. You build the table, you calculate element 1, you calculate cos, you calculate sine, you calculate cos square, you calculate CS, you calculate S square. Then from there, you just need to refer to table and substitute the number inside your answer. Okay, you use this K matrix. So for element 1, you calculate the cos. Cos equal to 5 divided by 5, you get 0.60. Okay, straight away from the diagram here. All right, cos theta means from here to here. You have 3 and 5. So straight away you can find the cos theta for element 1. Remember, in your answer, put the clear notation for element 1. Okay, you find this one, cos theta, you get maybe 0.5 or 1 mark here for the first one. Then you calculate the sine, the same. And after that, you build a table to find the cos square and so on. So it's good that you have the habit of building the table. Okay, building a table for cos and sine, or you can just draft on your answer. You find cosine, and then you find cos product signs and cos square, sine square. Then you put into the table here. Okay, I will expect the same answer, not same structure. Remember the symmetry one, the section here, you need to fill accordingly. And I show you the example as what you see on the screen here. All right, and you just substitute the area. Area is given. Elongation, elasticity modulus given. Length is given. Or not length given. Length is calculated just now. So you fill in all the value here. Okay. When you fill in the value, check this direction, all is positive. All this value in this direction or diagonal direction is positive. And also check side by side the mirror, side by side whether the number is correct or not. Okay. So is mirror, or we call it symmetry. It's the same. Okay. The number is repeating on the another side. Both sides is repeating each other. Okay, once you get this one, okay, you arrange it, and then you get a constant outside the matrix, and you look at you check the matrix format again. Once you get this one, all right, once you get this one, then you calculate for the second one. All right, you calculate for the element 2. Element 2, cos theta equals 0. Okay, cos theta 0, y 0, because you're calculating from x for element 2. You calculate from x to x prime. This is your x prime 2. You measure from here to here. Anti-clockwise positive. So, as you can see from here, you are looking at x and y axis. So x and y, the differences is 90 degree. So cos 90, 0. Sine 91. Okay, so in your answer, please write a clear notation. If you're referring to 2, put a bracket 2 here. Okay, or you just draw a line to differentiate element 1 and element 2, also okay. Okay, and it will be good if you write theta 2 equal 90 degree. So I will give you some marks for that one also. Okay, so it just shows that you understand how you see the data. Next, you just do the same procedure. All right, you just transfer all the value inside there. So you need to show your calculation. Don't go and straight away use the calculator. You need to show what is your A value, what is your E value, what is your L value, and what is the numbers in your matrix here. Then you calculate the constant value here. So as you can see, I did some transformation from here to here. I hope you can see the differences. Because this one, I need to do it equal to the previous one. Because for element 1, I get 2250. I need to calculate for element 2. After element 2, this component, I need to factor it until I get 2520. Okay, it will be times something. Okay, then I will get this answer. Maybe I'll give you 10 seconds to observe the differences between the equation in the middle and the last equation on the screen. Step here is that you need to factor, or you need to rearrange the value so that outside the matrix here will be the same as element 1. The reason is that because we need to superimpose. We need to park the number in a big matrix later on. So we need to align or synchronize the value. Okay, yeah. So do you get the idea?
Yes.
Okay, yeah. All right. Now before we move on, I want you to see the parking lot number. Okay, let me change my pen color. So you can use your ruler to draw a soft line. Like that. Remember, if you look at element 1 is this one. Element 1 is connecting point 1 and point 2. What does it mean? It means these two refer point 1, these two refer point 2. And same with this one, same with the side numbering. So you know that you are looking at X and Y axis. Okay, X and Y axis. So what does it mean? It means that the displacement is in the symbol of U and V. So the rest is just substitution of the symbol. So the first one is U1, V1. Second one, repeat U2, V2. Repeat the same for the side. These two, 0.1, these two, 0.2. So the first one, continue, U1, V1, U2, V2. Try to observe what I'm trying to write on the screen here with the green color. Let me know if you don't understand how to label the green color numbers or green color alphabet. Don't confuse, because once you confuse, you will get the wrong answer in your final answer. Okay, make sure you arrange them correctly in the correct sequence. All right, the first one will have 0.1. Second one, they have 2. So U1, U1, V1 first, then U2, V2. Same with the second one. You repeat the same for the second one. You use ruler to draw 4 lines or 3 lines. Okay, then you label. So element 2, you look at element 2 connecting 1 and 3. So what you do, you just label 1 and 3 here. And you expand the notation, the labeling. So again, you're also looking at X and Y. So you're also looking at U and V. So what you do, you just fill in U1, V1, and this one 3, U3, V3. Repeat the same over here. Just use your pencil to label because later you need to park the number in one big matrix to solve the external force. Okay. So this one is U1, V1, U3, V3. Stop me if you're not able to understand what we are trying to do here. Observe see the green color labeling that I did with my mouse. See anything that doesn't make sense to you, then I will explain to you. Okay, important part for element 2 is this one that I keep repeating just now. Is this one. You need to factor out until it's same with the element 1 or other element. Okay, make sure the outside the constant here is the same. If it's not same, you're not able to park your number. All right. Okay, once we have these two metrics, then we're going to solve F equal to KD again. You pull the F equal to KD, then you expand this equation. But before you expand, you need to find the K first, right? So I'm not going to repeat how you park. the numbers. Okay, so if you don't know how to park the number, refer back to the previous lecture, especially chapter 2. I asked you how to do the superimpose, how to park the location based on their parking ticket. Okay, so in here you just start with the K, you draw the you draw the lines, okay, accordingly. Okay, you draw the line, then you park based on the correct one. First point, point number 2, and point number 3. You have 3 points, point 1, 2, 3. So you just allocate each one of it accordingly. And because you're looking at X and Y axis, so each point will give you 2 displacement, X and Y. So each one will give you each axis will give you 1 displacement. So you're looking at U and V, same. So you go to the global matrix here. So you go just label U1, V1, and so on. U2, V2, U3, V3. Then you also use pencil to label the same. Okay, you find the K first. You find the capital K first. You park all the number. For example, this one, the first box here. First box is U1 and U1. So you go to the parking ticket just now. For example, this one. This is U1, U1. So you refer to this one. So you just park this number over here. Same with others. Repeat the same for other box. All right. As you can see, when you write F equal to KD, the constant value will be the same for matrix 1 and 2. Both are showing 250 and 250. Okay, so this is the area where 1 or 2 students will forget. This is the area that you need to be careful when you do before you do the superimpose. Before you park the number, make sure the constant value outside the bracket here is the same. All right, yeah. And then you repeat the same like what you learned in chapter 2. You just solve the unknown. Solve the unknown by calling the boundary condition. So boundary condition we already discussed. U1 equal to delta, which is 50 mm. Remember to change it to meter. U20, V20, U30, V30, and so on. So we can go to the general matrix here, F equal to KD, and we replace all the numbers in the matrix. And those with 0, we can temporarily close with your hand or with your ruler. So for example, point number 2, this one 0. So what you do, you go to row 3, column 3, you can close them. Row 3, column 3, you close, including the F2X, because 1, 2, 3, you can close. Then you repeat the same. This is V2 also 0. So V2 is number 4. So you close row 4, column 4. Same with the fourth in number 4. Repeat the same for U3. U3 also 0. So you close the 5th row and the 5th column. Same, you close F3. You close, I use the word close, it's not 0, but we close the number just to help us to focus, to simplify the solution. V3 also 0. So we can close the last row and the last column. You also close F3Y. So you only left out the one that I labeled with the dash box here. Okay. So on your side, you can also use a pencil just to draw, or you can just close it and then you copy the remaining matrix into a new line of your answer. Okay. So you are seeing F1X, F1Y, and you're seeing 0, 3, 6, and 0.8. And there's a number here. Brian, what is the number here? Can you estimate the number based on the screen? What is this number?
Where, sir?
Huh? Repeat again your answer. Not very clear on your side.
The number where, sir?
Yeah, what is the number that you
Over.
should fill in here? What is the number? Based on this screen, what is the number over here? Brian, are you there?
Yes, but my screen went off.
Okay, I will give the chance to Ashma. Are you able to solve what is the number of the question mark that I label on the screen here?
0.48.
Yes, correct. So you able to understand why 0.48 now? Sue, are you able to see why this one 0.48?
Yes.
Okay, good. So the rest is just solving the simultaneous equation or 2 times 2 matrix. Okay, so I can write because your F1x here, as you see on the right hand corner, that are labeled with green color line. So this P is this one, right? P is going to the left. Okay, so you can calculate. You can calculate based on the answer here. So I'll just expand. I'll just expand and then you solve the equation here. So basically you are having 2 equation over here and you solve. Okay. So you'll get your V1 equal to 0.0337 meter. Okay. All right. So what does it mean by positive 0.0337 meter? Okay. Again, V is Y component, we did this one. Y component positive, it means it moved to the left. For this module, there will be one particular section that will ask you to explain your answer. What does it mean by your answer? Where does it move? You have to know. Huh? So in this case, you have positive, means it moved to the left according to the Y direction. All right. Then you continue solving. So for element 1, you look at element 1 because we need to solve the forces inside element 1. So actually you are looking for small f. And every time you deal with small f, you call the standard equation F equal to KD again. Okay, F equal to KD. And in this case, the K is the one that's standard for element. Okay, so also AE divided by L and 1, 1, and so on. Okay, 1, positive 1, minus 1, minus 1, 1. Okay, yeah. Okay, or you can call from the general equation here. Okay, let me label with a more, I use purple color. So if you look at element 1, sorry. If you look at element 1, which is here, element 1 connecting 1 and 2. So basically you're looking at this one. So element 1 connecting point 1 and point 2. So actually you're looking at this section. And this section. Okay, but however, remember you already combine all the number here. So it's good that you need to recall the individual formula where we got, let me show you the original formula with this one. as you can see on the screen here. When you look at individual element, you are looking at F equal to KD. So F equal to K, this is your K, AE divided by L1, positive 1, minus 1, minus 1, 1, this is your K. D is a usual one. D is U1 and U2. Okay, so you repeat the same for this case. Right, now as you can see here, your F equal to KD, your K, right, and your D, right, K and your D. So your U is given, U1 is given because U is 50 mm. Remember the negative sign. It's negative because it's going opposite your X direction. And V1 you already found just now. U2, V2, 0. So you managed to solve using a triple multiplication of your matrix. Okay, so from there, you managed to find F1x equal to this one, F2x equal to this one. So what does it mean if you have a negative sign? What does it mean if you have a positive sign? Okay, so you draw the, let me see if I ready the free body diagram for you. Okay, now you draw element 1. And you are having the, this is a point 1, this is a point 2. And remember, your axis is like this. Your X and Y. So for X1, you have a negative, right? So how do you draw in the free body diagram? Your negative means it go opposite the X direction, your X axis. So your X positive to the top here. So when you get a negative, it means the forces is pointing down. This is your F1x. Small f with the this one. Hey, sorry. I did the wrong one. Apologize. Okay. So this is a F prime. Sorry. I did a mistake just now. X prime means you're referring to this X axis. X prime. How you know the arrow? You look at the diagram. The arrow of the X prime will be given. So you just follow the X prime. If it's positive, means you follow the X prime. Here, your F1x is negative. So what does it mean? It means that when you look at the element for point 1 negative means it's go this way. 76.6 going another direction. For point 2 positive, it means it's follow the X prime. So this one 76.6 kilonewton. So if you have two force pulling at both ends, the result of this action, we call it tensile loading. Okay, tensile loading or tensile behavior. Mean tensile load, we call it tensile loading behavior. Means you pull at both ends.
So,
Any question? Yes.
So the body will be in equilibrium.
Yeah, based on your calculation, it balanced and it should be balanced I mean, from this case, you get a balanced force because you only have one force P there. Of course, when it comes to your test or exam, I will add one more, a few more forces there, and the forces might not might not be the same. But what is important for this exercise is that you know how to draw the arrow, where the red color arrow, whether it's how it's going to point. That is more important. Yes, in this case, it's a symmetry. Means you have the same forces at both ends. Do I answer your question?
Yes, sir.
Okay, yeah, everyone clear? Important that is you should ask yourself, do I know how to draw the arrow or not? Okay, you just copy the element and then you copy the x prime axis because you are solving f prime. F prime means element. So f prime you need to refer to the axis itself. Then positive means you follow the direction. Negative means opposite the direction. Okay, you did the same for the second element. Do you see it now? Or is
So
still anything you're not? Yeah, go ahead.
So if it's in the case of F1 Y.
Yeah, you don't confuse with the x and y. Don't mix up with these two axes. We are looking at x prime. X prime means you're looking at the purple color that I draw on the screen here. Okay, don't confuse with the x and y, because now we are solving f equal to kd using the prime, s prime symbol. We're looking at element now. So what you found in the answer referring to the x prime axis or y prime axis. It depends on what you find. Okay. Same, repeat for element 2, f equal to kd. But again, you're seeing I use back the original one. I will no longer use the 225 something, but I use the original one, 31500 kd. I substitute the answer. U1 already fine, given. V1 already fine. And the rest is just multiplication of your matrix. So for element 2, you have 1061 kilonewton, F 1061 kilonewton. So how do you draw in a free body diagram? You copy the element, draw the F prime axis for element 2. Element 2 have 0.1 and 0.2. Be careful on the x prime axis. So x prime 2 is going to the left, as you can see from the diagram here. So this is x prime 2 axis. Okay, just to test whether you understand now, I'm going to ask Sue, are you there?
Yes.
Sue, you look at point 1. What does, this is element 2. So what is the direction of the point at this point? Does it go to the left or go to the right?
Go to the right.
Go to the right, like this.
Yes.
What does this answer give you? Positive or negative?
Positive.
So what does it mean? It's positive. What is the x prime, f prime mean to you? You're referring to which axis? Okay, I redraw the whole diagram. You are now looking at element 2, we did this one. Okay. So you just copy the shape of element 2. You have a 0.3, 0.2. Then you draw the axis. This color axis is what? Is x prime or x? Which one? So
Yes.
X.
X prime.
X prime. So because why? Because you're solving for F prime. You're solving for element. Element is prime.
Okay.
Then you look at the diagram. Where is your X prime 2 direction? To the left or to the right? Positive.
Oh, X prime is for F
To the left, right?
to the left.
Mm.
So it positive is to the left.
Mm.
Okay.
So you have, this is element 2. Don't confuse that with the element.
Okay.
3 and 1. So you have your F2 prime axis to the left. Okay, now I want you to try to explain to me the direction of the force, because you already found the answer already, F1x positive, 1061 kilonewton. So it means at point 1, where is the direction? Pointing to the left or right?
Left.
Pointing to the left like this, right? This is your F prime 1x. It is 1061 kilonewton. You understand this one, point 1, Su?
Yes.
Okay, now explain to me what happened to point 3 based on this answer. You get a negative. Where does it point? Point to the left or point to the right?
It points to the right.
Why? Why point to the right?
Because it's negative.
Negative, and then your x prime direction is to the left, right?
Yes.
So this one is your F prime 3x, the 1061 kilonewton. Okay. So, okay, so you understand, huh?
Yes, yes.
Okay, good. Others, any one of you is still confused with the purple color arrow? Any one of you is still confused? I can explain one more time. All right. Now, if you look at the diagram on your screen here, the purple color line, the arrow, is both pointing inside. This behavior gives you compression. You compress the thing. Apologize for my writing. You compress the object. It means element 2, yeah lah, is logic lah, based on the normal forces you acting. You push something to the left and point 3 cannot move. You're compressing this element 2. So it agree with the normal behavior, with its logic, with its agree with the calculation here. Okay, so this is how you analyze your result, whether it's logic or not. When you press something or you pull something, does it logic with the force inside the element? Okay, so make sure you understand this one. All right. Okay, let me stop the recording.